Welcome back to another very exciting asynchronous lesson. Today we are going to talk about special right triangles. We're going to look at a few examples. I want you to spend some time convincing. If this is a 90-degree angle, 45 degrees, this of course has to be 45 degrees, right? So we have a 45, 45, 90-degree triangle. And if this is 5, because these are both 45 degrees, this is actually an isosceles right triangle. This also has to be 5. You can convince yourself of that if you needed to. But if we were trying to solve for the hypotenuse, I want you to notice what happens. We get something like x equals the square root of 50. And I don't know how much time you've spent before simplifying radicals, but here essentially we want to pull out any square roots that we can. So to simplify this radical, I can actually think about it as 25 times 2, where 25 is a perfect square, right? The square root of 25, we know it's 5, which ends up allowing me to simplify this hypotenuse as 5 root 2. Notice the sides were both 5, the legs were both 5, and the hypotenuse now is 5 root 2. Let's take that one more time. This time, the leg is 3. Of course, it's an isosceles right triangle. This leg is 3. In solving for the hypotenuse, I'm going to get the square root of 18. And as we pull out any perfect squares, because we added 2 perfect squares, I can rewrite that as 9 times 2, where again, we know the square root of 9 is 3, so it gets to come out of the radical. And I get that the hypotenuse is 3 root 2. When the legs were 5, the hypotenuse was 5 root 2. When the legs are 3, the hypotenuse is 3 root 2. This is not a coincidence. This is indeed a pattern. Anytime we have a 45, 45, 90 right triangle, let's suppose we knew, let's change our variables a little bit. We knew that the side length was x. Whatever x was, this is also going to be x. And when we go to solve for our hypotenuse this time, we see that something like this. H would equal the square root of 2x squared. But we cannot square root 2. We don't know what the square root of 2 is. We do know the square root of x squared, though. The square root and the square cancel these out, so we get left with x times the square root of 2. And we can use this pattern for any 45, 45, 90 right triangle. So, if I'm trying to solve this triangle, special right triangles are a shortcut and a speedy trick that you'll see a lot in standardized testing. If that's 7, this is 7, and following our pattern of x root 2, it's like a chair. This would be 7, 7, 7 root 2, and that's it. Of course, let's say we didn't have a 45, 45, 90 right triangle, but instead we have this thing, where we have a 60-degree angle. And so you're following, you're thinking, 60 degrees, that means up here is 30 degrees. And here's what I want you to visualize. Anytime we talk about a 30, 60, 90 right triangle, I want you to visualize that we had an equilateral triangle that we cut in half. So here, forgive my poor equilateral drawing, but this would mean that every angle in the triangle was 60 degrees, which would mean that every side of the triangle was the same. So before I cut this in half, right, so we're picturing that I cut it in half to get my bottom base of 5. Before I cut it in half, that means this whole base was 10. So we can kind of see if this is 5, the whole thing, each of the sides would have had to be 10, which tell us right away what our hypotenuse is here. On a 30, 60, 90 triangle, if we can visualize that triangle as half the equilateral, we can find a relationship between the base and the hypotenuse. And of course, once we have 2 sides of the right triangle, we can go ahead and solve for this third side. Let's take a look. x is the square root of 75. And just like we did before, we want to pull out any perfect squares. We can think of 75, think about your quarters. That is the same as 25 times 3. And we can then conclude x square root of 25, we know, would be 5 root 3. So for this triangle, I can see that x would be 5 root 3. Let's look at that one more time. This time, let's say the base is 3. And because we are great visualizers, we know the 30, 60, 90 right triangle is half of the equilateral triangle, which means this base was half of the hypotenuse, so the hypotenuse would have been 6. Each side would have been 6. And once again, solving for that missing side would look something like and once again, we would be trying to pull out any perfect squares, and as you're thinking about it, you know that 27 can be split up as 9 times 3. 9 being our perfect square, the square root of 9 we know is 3. And that would leave our answer for the height here as 3 root 3. Maybe you're seeing the pattern. The previous triangle we had it as 5, 10, and 5 root 3. Now we have it as 3, 6, and 3 root 3. To generalize that pattern, for the 30, 60, 90 right triangle, whatever the base is, the hypotenuse is twice the base, thinking about the base being half of that equilateral triangle, and then the height would be the base times the square root of 3. And this pattern works for the 30, 60, 90 right triangle every single time. All right, leveling up the game. For your asynchronous assignment, I've got 3 triangles, each with a hypotenuse of 1. Can you solve for the other missing sides? Good luck. Let me know if you have any questions. I look forward, as always, to seeing your work.